Hello and welcome to Inequivalent Equations. I am Mr. Harris, and today you will need paper and pencil. So let's start out with solving. Solve the following quadratic in whatever manner makes sense to you. So we've got x squared minus 1 equals 3. Give that a shot, see what you can do. Come back to me when you have something. So in the past, whenever we get an equation, we tend to put everything on one side and set it equal to 0, and then try and use some process to find the zeros or to solve or factor or use quadratic equation. And you can also create a table or graph to find the solution to this. So if you don't have a solution yet, if you haven't done so, go ahead and create a table and a graph and solve it that way. So give that a try. Come back to me when you have it. So here we've got, I use Desmos, and so here's my graph with my table. And I subtracted 3 from both sides, and I got x squared minus 4 equals 0. And then I put the x squared minus 4 into Desmos, and it graphed it. And I created the table after fact, but you can create the table first and then graph from the points you get on your table. And you get a parabola that looks like this. And so it goes through -4, and it goes through the points -2, 0, and 2, 0. And so that is our solution. Our 2 and our -2 are our zeros. Now, in that process, I put everything on one side so it was equal to 0 and I solve. But what if we took the same equation, the x squared minus 1 equals 3, and instead of moving our 3, we just use what's on our left side to plug into Desmos and see what we get. So I would like you to do that. So go ahead and plug in the x squared minus 1 into Desmos and compare it to your previous graph. And so you may have to put both graphs on the same page in Desmos. It'll do that for you. And when you have the two graphs, I want you to explain how they're related, or think about how they're related, and tell me, do you get the same solution? And how is it you know you get the same solution? So you've got 3 things to think about on this one. So go ahead and graph that, compare it to your first graph, and then deal with these 3 questions. When you have something, come back to me. So here's my graph of the left side of the equation. So I just put the x squared minus 1 in, and I get this parabola. And so now I put both of my equations on one graph. And so here was the first one, the x squared minus 4. And remember, it's an equation, so it actually was x squared minus 4 equals 0. And our second one is x squared minus 1 equals 3. And so we actually have 2 separate graphs. And so our first question was, can you explain how the 2 graphs are related? And so when we look at the 2 graphs, we see that it's the exact same parabola. It's just shifted up by 3. And so when we had it set equal to 0, it goes through the point 0, -4. And when we didn't, we've got to leave the 3 on the right side. It goes through the point 0, -1. But the parabolas are exactly the same. They are, if we moved this down, they would overlap. And so that is how they're related. The same parabola, just shifted up 3. Now, the second question was, does the second graph give us the same solution? And so we have to think about what are our solutions. So in the first one, we said x squared minus 4 is equal to 0. So we're looking for our zeros. But now let's think about what that really means. When we say our zeros, that means the place where our graph crosses the horizontal line that is y equals 0. And so it crosses at 2 and negative 2. But this equation is set equal to 0, so it makes sense that we're looking for where it crosses the y equals 0 line. But in our second equation, it's x squared minus 1 equals 3. So we should be looking at not where it crosses 0. It crosses 0 at negative 1 and 1. But we should be looking at where does it cross the line 3. So up here at 3, y equals 3, our parabola crosses the line at 2 and negative 2. And so we do in fact get the same solution. But that means when we set it equal to 0, that was telling us that we're going to look at where it crosses the y equals 0 line. If we don't set it equal to 0, we leave it equal to some other constant, then our solution is going to be wherever it crosses the line that is the constant on the right side of our equation. And so in this case, it was 3. So since y equals 3, we look at the line here, and we get 2 and negative 2. So both of them have the same solutions. The big idea here is when we create graphs at different points in our solving problem, or process rather, we should always get the same solution. So here our x squared minus 1 equals 3 was our original equation, and here we was one step into our solving. And so we should still get the same solutions because it's essentially the same equation that we have just manipulated. But we may not get the same graph. So you have to know where you're looking on your graph to get your solution. The solutions happen in different places based on what our equation looks like, how much we have manipulated it. And so that gives us the illusion that we're getting inequivalence, although we will still get the same solution. So the second part of our big idea is when we're solving using the square root, we usually have a square term on one side and some number on the other side. And so in our other solving processes, we tended to have a 0 on one side and everything else on the other side. But now we are very purposefully creating a situation where we have some number on one side and our square term on the other. And so this scenario is going to come up much more because we're not going to be solving an equation that has a 0 on one side. And so we may have to look for some other place where our solution happens. And so keep that in mind as we go on. So now we're gonna go through a couple of problems to give us some examples of this. So go ahead and solve this by taking the square root. And this is the one we just looked at. We solved it by graphing before. So now I want you to solve it by taking the square root. And our first step is you should get x squared by itself. So whatever the square term is, you're trying to get it by itself and everything else on the other side, which is a little different thinking than what we're used to. So give that a try. When you have something, come back to me. So we start with our original equation. We add 1 to both sides, and that gives us x squared equals 4. Now we take the square root of both sides. So we get x equals the square root of 4. And what is the square root of 4? X equals 2 and x equals negative 2. And in our last video, we talked about when we have a radical, if we're given a radical, we just assume the positive value. But if the radical happens in a process of our solving, then we have to look at both the positive and negative. And so because we created the radical, it wasn't given to us, we have to look at both the positive 2 and the negative 2. And we already know from our graphing that 2 and negative 2 is the solution for this equation. And so this is how you would do it algebraically by taking the square root of both sides. And so because we have 4 on one side, when you graph it, you're looking at where does the graph hit the line y equals 4. And so that's where we get our 2 and our negative 2. So let's do a little thought review. So in our previous problem, we had a radical and we used both the positive and negative values of the square root. But when we were given the radical, we don't. And so, I want you to articulate why that is. How would you explain that to someone else? So write down your explanation for that. When you have that, come back to me. So once again, and I review this point because it's important. When we're given a radical, it's assumed to be the positive value. When we create a radical as part of our process, we've got to look at both the positive and negative values. And as you know, with a quadratic, we often get 2 roots. And so that's where the 2 roots come from when we do a square root of a number and we look at both the positive and negative. And so keep that in mind as we work. Now let's do a few problems and sort of get this concept in us. So for these 2 problems, solve for x and use the process of taking the square root of both sides. When you have something, come back to me. So in our first one, our square term is by itself. So we simply take the square root of both sides. We get x on the left side, and we get the square root of 36 on the right. And what number times itself gives us 36? And that would be 6 and negative 6. And so our solution is x equals 6, x equals negative 6. For our second one, our square term has something else on the same side with it, and so we've got to isolate our square term. So you subtract 3 from both sides. So 3 minus 3 gives us the 0 here, and 52 minus 3 gives us 49. So we end up with x squared equals 49. Take the square root of both sides, you get x equals the square root of 49. Square root of 49 is 7 or negative 7. And so that is our solution. Got the hang of it? Let's try another. Can you solve for the x in this equation by taking the square root of both sides? So give this one a try. Come back to me when you have something. So this one looks a little different than what we've had. We've got x minus 2 quantity squared. But our rule is you got to get the square term by itself. And so since it's in parentheses, this whole thing is our square term. And so since the square term is by itself, you're ready to take the square root of both sides. So when you take the square root of this, just the square here drops away and it leaves you with the x minus 2. And you take the square root of the other side, which is 25, so you get the square root of 25. So now we've got to think of this in terms of 2 equations. Before we ended up with an x on the left side, and we could say x equals 5 or x equals negative 5, but here we've got an x minus 2. So we have to say x minus 2 equals 5 and x minus 2 equals negative 5. And then you solve for each of the x's in the 2 equations. So here we're gonna add 2 to move this, to get this to the other side. And when you add 2 here, you got to add 2 to the other side to keep it balanced. So x ends up equaling 7. And once again on this one you're going to add 2. And so you end up with x equals, and negative 5 plus 2 gives you negative 3. So here your answer is 7 and negative 3. So when you have something where your square term is not just simply x. You might get an answer that's not the same number and it's negative. So, in the previous problems, we were getting 5, -5, 2, -2, but here we get a 7 and a -3. So just by looking at it, you should be able to tell I'm going to get two numbers that are not the negative of each other. So let's try another. So here we've just added a little more stuff, but you're using the same process. You're going to take the square root of both sides, and so the thing you got to do first is to isolate the squared term. And so give that a try. Come back to me when you have something. So here we've got to do a little manipulation of our equation first. And so we've got 2 times our squared term, which is x minus 1, minus 4 equals 10. And so we got to get rid of a few things, our 4 and our 2 here, just so we can get our squared term by itself. So to get rid of a -4, you got to add 4 to both sides. And when I add 4 to both sides, my -4 disappears, and I end up with 14. 10 plus 4 gives us 14. And so now I want to get rid of my 2 here. So I can divide both sides by 2, and then this 2 will fall away, and our 14 divided by 2 gives us a 7. And so now I've got my square term by itself equal to 7. So I take the square root of both sides, and I end up with x minus 1 equals the square root of 7. The square root of 7 is not a perfect square, so it's going to be some ugly number. We know the square root of 4 is 2, and the square root of 9 is 3. So the square root of 7 is going to be somewhere between 2 and 3, and it's going to be a decimal number that doesn't repeat and does not end. So we should leave this in radical form. So that means we will say x minus 1 equals a positive square root of 7, and x minus 1 equals a negative square root of 7. And our negative is on the outside of our radical. And so now we want to get x by itself. So since it's x minus 1, we're going to add 1 to both sides, and we'll end up with x equals 1 plus the square root of 7, and x equals 1 minus the square root of 7. And so that is your answer. So you don't have to turn the square root of 7 into the ugly number between 2 and 3. Just leave it as the radical, and you've got the positive and the negative value, and you don't have to combine them. So that's how it looks. Let's try one last one. So take the square root of both sides, and let me say we just happen to have our square term on the right side instead of the left side, and it absolutely does not matter. But if you prefer to have your square term, your x's all on the left side, you can flip your equation. That's a perfectly allowable math move. And so do this however makes sense to you. When you have something, come back to me. So here we've got to get our square term by itself. So let's start by subtracting this 4. And so you subtract 4 from both sides, and you end up with -2 times the quantity x minus 3 quantity squared, and with a 0 on our left side. And so now we want to divide both sides by our -2. And so 0 divided by -2 is still 0. And on this side, this quantity divided by the -2, our -2's cancel out, and we end up with the quantity x minus 3 squared. So then we take the square root of both sides, because we have isolated our square term. And the square root of 0 is 0. And on our right side, we've got x minus 3. So we take the square root and our squared drops away. And so now we've got 0 equals x minus 3. And now I'm flipping it, and I'm going to solve for x. So to get x by itself, I want to add 3 to both sides, so x equals 3. Now this equation only has one root, because our square root of 0 doesn't have a positive and a negative. It is simply 0. And so you should see that the pattern here is, if you get a 0 while you're solving, if you get a 0, then you know there's only going to be one solution. And so let's graph. Here's the first place where we get our 0. So we've got the negative 2 times the quantity x minus 3 squared. So let's graph that. So here we have the graph of 0 equals negative 2 times the quantity x minus 3 squared. And we see that it only touches, it just kisses the y equals 0 line. So there's only one point where the graph intersects the axis. And that single point is 3, 0. So in summary, when we have a squared term in an equation, we can take the square root to solve. And when we take the square root, there's a positive and a negative square root. Unless, of course, it's 0, then you get a single. Now, when you have a radical, you usually leave it as a radical instead of converting it to a decimal. And so if it does not, if it's not a perfect square, then leave it as a radical and use the positive and the negative of that radical. And remember, the positive and negative are outside of the radical. When we solve by taking the square root of the term, we get the squared x term by itself on one side of the equation. And it doesn't matter which side. And so you can choose, if you like everything on the left, you can do that. But you get it by itself. You isolate it. Sometimes when using a different process for solving, we may get different graphs if we graph different places in our solving process. And so even though we may get different graphs, we should understand that they should give us the same solution. And so it all depends on, you have to think about what is your equation, in your equation, what is your square term equal to, and where on the graph you need to look to find your solution. And as always, quadratics are your friend. And so thank you for coming. Thanks for watching. Have a great rest of your day.